Hey guys, Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And tonight, another one of your favorite subjects, Algebra 2 and radicals. So the square roots. Hey, let's get after it. Only 3 problems, but I think each has a little bit of a different twist so you can get a feel for how to operate. In general, if you just think about something under the radical sign as being like the denominator in a fraction. Okay, if you'll think about that, you can't add like 1/3 plus 2/4. These are apples and oranges, mangoes and saging. Okay, you can't add them until you put them into the same form. Radicals are the same. So let's think about that. Now there's a few rules we need to look at first. If I have the square root of a times b, I can rewrite that as the square root of a times square root of b. Okay? So if I have some number like 8, I can separate that square root of 8 out, which I have square root of 8. Why not I change that into the square root of 4 times 2? Now using this which would be like this, but using this concept, I can change that square root of 4 times 2 into the square root of 4 times square root of 2. Whoa, well what is the square root of 4? It's 2. So 2 square root of 2 would be what I could change that 8 into. So let's think about that. 4x minus 2 square root of 2. Equals, well, let's see, now I have a square root of 72. Well, if I go with this same concept, 72, 9 times 8. So now I could say, well, the square root of 72 equals square root of 9 times 8, which is the square root of 9 times the square root of 8, but we said a few minutes ago, square root of 8 was square root of 4 times square root of 2. Okay, so now I have 3. Square root of 9 is 3. Square root of 4 is 2. And we'll leave that square root of 2. So all this becomes 6 square root of 2. So I can take that 72 and replace that with 6 square root of 2. So square root of 72 is equal to 6 square root of 2. Well, now, it's beginning to get more and more simple, isn't it? Okay, I need to add, since this is a negative 2 over 2 square root of 2, I need to add a positive. So now I have 4x minus 2 square root of 2 plus 2 square root of 2 equals, what you do to one side, do to the other, 6 square root of 2 plus 2 square root of 2. Well, now you can see I have 6 of something plus 2 of something. Well, what does that give me? 8 of something. If square root of 2 was a banana, I have 6 bananas plus 2 bananas. I would have 8 bananas. So just keep it that simple, okay? All right, so negative 2 and a positive, or negative 2 square root 2 plus 2 square root 2, those cancel, leaves me 4x equals 6 square root of 2 plus 2 square root of 2 is 8 square root of 2. Okay, now just divide both sides by 4. 4 divided by 4, those cancel. X equals 8 divided by 4 is 2 square root 2. Well, let's see if that's correct now. If I plug that back into here, because we had just taken these numbers and converted them, x becomes 2 square root 2. 4 times 2 is 8 square root of 2 minus 2 square root of 2 gives me 6 square root of 2, and that's equal to the square root of 72, or 6 square root 2. Okay, one down. What about this guy? This one looks crazy. Okay, 3x times the square root of 1 over 3x plus the square root of 300 times x. Oh, well, let's work with this side first. One thing you can do with things under the radical is if I wanted to change that denominator to a perfect square, how would I do that? Well, I could multiply it by 3x over 3x. I multiplied that times 1, so that's okay. That would still give me the square root of 3x. You know, when you multiply fractions, just multiply numerators and then multiply denominators. I end up with 3x times 1, which is 3x, over 9x squared. So 3 times 3 is 9, x times x is x squared. Okay? Well, how does that break down? Another rule of square roots, if I have square root of a over b, that can also be the square root of a divided by square root of b. Hey, think about that. Or if I change this out to multiplication, I could say 3x times the square root of 3x times the square root of 1 over 9x squared. I could change it like that, and I wouldn't have to do this. But if I take square root of 1, well, I guess I could do it that way now. I could change it like this. There we go. Okay. So I've got 3x times the square root of 3x. Square root of 1 is what? 1. Square root of 9x squared is 3x. 3x over 3x gives me square root of x. Okay. Now, that's the left side. Let's go back to the right side now. We still have all of that to work out. All right, square root of 300x. I could say that's, let's see, if I want to get perfect squares here. Well, let's see. Let's just kind of get on a scratch pad here. That's 30 times 10, right? If I'm just on the inside. Well, 30 is 6 times 5. 10 is 2 times 5. 6 is 2 times 3 times 5. I'm going to move this 5 over, times 5 times 2. Let me group the 2's together. 2 times 2 times 5 times 5 times 3. I still have that x out here. Forgot that guy. That. Now then, all of that, recall, is under the radicals. So now I have square root of 2 times 2 is 4, times square root of 5 times 5, which is 25, times square root of 3x. So that 300 now becomes, square root of 300x becomes, square root of 4 is 2, square root of 25 is 5, times square root 3x. So it's 10 square root 3x. That's what the square root of 300 would be. Okay, so that's 10 square root 3x. That's what all of that reduced down to. Or actually not reduced, we just changed it to a different form. Okay? All right, so now we have, let me bring this guy on down, 10 square root 3x. Okay? So what did we have here? Square root of 3x is what we had remaining, plus 10 square root 3x. Well, if I have 10 bananas and 1 banana, I have 11 bananas, okay? I have 11 square root 3x. So that would be my answer. That was kind of a cool problem there. All right, let's go to the big eraser here. But this one may be a little bit more cool. It has a variety of things in it. I hope you guys had a wonderful day and you studied, you've been learning, expanding your mind. Oh, before I forget it, get involved in a local school, buy a kid a book, okay? Here in the Philippines, a lot of kids in school don't have books. That's a crime. We need them to have books and learn, okay? All right, with what we did with the square root of 8, how we changed that, we factored it a little bit. Let's do that with each one of these and see what happens here. I'm going to scoot over just a little bit. All right, square root of 12. Well, that could be, what is that, 6 times 2? Well, 12. Now, let's go with 4 times 3. Stick with that perfect square concept. Hey, almost messed up there. All right, that's square root of 4 times square root of 3. Plus square root of 4 times square root of 5. Okay. Uh-oh, what do we do here? Square root of 9 times square root of 5. Oh. Let's change this one into a perfect square. I can multiply it by 1, which is 3 over 3. So that gives me the square root of 3 over square root of 9. Square root of 3 over 3. Okay. Alright, so let's kind of, well, let me change this one here. That'd be, I'm going to go ahead and take square root of 9, and I'm going to move that out here to, say that's 1/3. Square root of 9 is 1 over 3, so I'm just going to move that 1/3 to the outside. Now then, you'll notice I can collect some terms together. I have the square root of 3 here and the square root of 3, and I have the square root of 5 and the square root of 5. And I need to simplify also, don't I? Okay, I have the square root of 4 is 2, 2 square root of 3, and I'm going to move this plus 1/3 square root of 3. So I've got taken care of those two. Now, plus square root of 4 is 2 times square root of 5, minus square root of 9, which is 3 square root of 5. So I've taken care of 4 terms, 1, 2, 3, 4. And I've put the square root, 3 square root of 5. Hopefully you were looking in the monitor going, wow, he missed it. Actually, I missed that earlier when I worked it also. I didn't learn anything. Okay, 2 square root 3 plus 1/3 square root 3. Well, I could change that to a common denominator. Multiply that by 3 over 3. So I have 6 square root 3 plus 1 square root 3, both over 3. Plus, well, actually it's going to be minus, isn't it? 2 square root of 5 minus 3 square root of 5 is minus 1 square root 5. So 2 bananas minus 3 bananas, I have a negative 1 banana. I don't know what a negative 1 banana looks like, but if we had bananas, we'd have a negative 1 banana. All right, so what do I have? 7 square root 3, 6 plus 1. 7 square root of 3 over 3 minus square root of 5. And that, my friend, is the answer to that one. Yes, and I have the answers over there just in case. Okay, these were some rules associated with radicals and how we can use those. Hopefully you enjoyed this one. Why are we doing this? Hey, together we're trying to build a better tomorrow and trying to do that through math. Enhance our skills, get better at our job, be able to get a job, okay? There's a lot of things you can do with math, especially in today's world. Man, it's more of a requirement that we have good analytical, good STEM skills. So let's get those, okay? All right, that's enough for now, and we'll talk to you next time. Thanks.